is going to go. All right. Well, that's a good question. How is today going to go? Today we're going to have our latest installment in your favorite CISS226 game, Clear and Fuzzy, where we're going to discuss the latest project that you have, the library check-in and check-out, and we're going to focus on the fuzzy stuff. I want you to note in your own mind what part is clear, but I'm really interested in discussing the fuzzy part. I think it's important because, again, I've sort of talked about this before, but anytime you have a programming assignment, you should look at it and sort of take inventory of the pieces of it that you know and the pieces of it that you're pretty sure you don't know, like the part that seems confusing to you. I'm first going to, before we do that, I'm going to talk about what is required for the next piece of it, because you had your design, you have sort of a first pass at it, and then probably you'll have a final version. So this will sort of stretch out over 3 weeks. But I want to talk about what I would like to see in what's due next week. All right, so we'll do that first. Then we'll take inventory of the fuzzy parts. Mentally think of what's clear for you. In fact, I will probably ask you what's clear. We just won't spend as much time on it. Then I am probably going to skip. I'm probably going to grade in a different order than it was turned in. I'm going to grade your designs before I grade your lab 6. So I'm going to grade lab 7 before I grade lab 6 or something like that, because one of them is a design, and I want to make sure that's correct. I will do that up in lab, depending on how it goes today. If we do not take the full time, the remainder of the time will be work time for you to work on your stuff. All right. So I'm going to explain what's expected for the first pass of the lab, the coding part of it. I'm going to ask you for your clear and fuzzy parts. We will talk about them, and then if we finish early, we'll go up to lab, and I'll be grading your designs then. So if you stay for lab, I will talk to you about it then. If you do not stay for lab, be on the lookout for my notes concerning that. What else? Oh, and remember, being a Wednesday, I need to leave right at 10 to 3. All right, so this is what we have for the lab. I think that's everything. This is pretty much what I was going to do on Monday, so we're just sort of a half day behind, or 1 half week behind, 1 session behind. Okay, the assignment was to create something for books and other library materials. So in a nutshell, you need to allow patrons to check out and check in books. So if you check it out, you need to keep track of when it was checked out. In addition, there's some restrictions about checking it out. Namely, a person can't check out more than 10 items. A person can't check items if they have more than 3 overdue items. A person can't check out a book that's already been checked out, that someone else has out. So there's restrictions. And finally, you check it in, and when you check it in, you clear out the fact that it's been checked out by someone, and also you return if there is a overdue fine. And that overdue fine depends on the kind of material. In a nutshell, at the 25,000 feet overview, that's what this assignment entails. All right? And you need to be able to do that. Now, the thing that is due next week essentially says do something. All right, to paraphrase this. Make as much progress as you can writing the code for the design defined in Lab 6. Turn in and review with me during lab. So probably Wednesday next week in lab. Thank you. We will review what you've turned in, and I will probably grade it on the spot. All right, it's a good way for me not to get behind in grading. It's just to grade stuff on the spot with you and review with you and to look at trouble areas and what you need to go. So this is pretty open-ended, right? And don't take too much comfort in the fact that it says do as much as you can, because you got to kind of finish it up next time. All right, so you want to get as much done as possible. So what are some approaches that you could take to this problem that wouldn't require you to do everything? Because obviously you could do everything and turn it in and then just skate on your laurels for another week. All right, but that seems like a lot. So if you're going to break this down into pieces, what could you do? Let me tell you my thoughts on this. There's two ways that you could trim this problem down and make some progress on it without completing the whole thing. And you can do either of these two things, or you can pick none of the above. But in my mind, to show progress, you probably need to show some sort of output. All right? Because if you have code that checks out a library book and you run it and you don't get an error, it would kind of be a shaky assumption to assume that everything that worked, right? If, however, you can check out a library book, return it, and then say, well, gee, it said that there was no fine and there wasn't supposed to be a fine. Or it said that the fine was $2.85 and the fine was supposed to be $2.85. That's a win, right? That's a way that you can prove that it worked. So how can you trim this down? I see two main ways that you could do this. Where you could trim it down, still get output, and yet not have to write the whole thing. One of the things would be to not worry about the restrictions when you check out. All right? There are 3 restrictions. You can't have more than 10 books, you can't have more than 3 overdue books, or you can't check out a book that's been checked out by someone else. Okay, don't worry about those for your first pass. Just check them out. And if someone wants to check out a book, they can. Just let them do it. All right, without doing any sort of verification or validation or anything like that. Now, to be sure, next week you're going to have to put that code in. But at the very least, you could get started and accomplish something without accomplishing everything. That's always a programmer's challenge, is how to accomplish something without accomplishing everything. Because everything often is a big deal. So if you can at least get some of it done, then you're putting yourself in the right direction and you're ahead of the game. The other thing that you could do is you could just return a flat library fine if is overdue without paying attention to the kind of material it is. All right? Maybe you only get one of the kinds of materials. Maybe you get things working for books and you don't worry about DVDs. Or maybe you just make it a quarter-a-day flat fee and return that, or something like that. These are all ways that you could, it's another way that you could trim down the scope of the problem and still make tangible progress on it. You can mix and match these things, right? You know, you could make absolutely no restrictions on checking out a book, and when you check in a book, you could just return, return something as a fine without doing the actual fine calculation. So you could do A, B, or A and B. Or you could come up with some other mix to make it work. But those are the logical things that I would think of how you can trim this down without accomplishing the whole thing. Questions on any of this? All right. Clear and fuzzy. Let's go around the room. Start up here. What's clear about this project? What's fuzzy about this project? Okay. Okay. Now that was a confusing part, right? Okay, what about clear? Okay, we can come back to you if you okay. Next.
The classes are clear to me, and I have to research it. The methods, one that confused me the most, I guess right now that I'm plugging on is the validation, exactly where to put that. After the baby, put that in.
Why is that not showing? Oh, there we go. The validation method. Okay, so the methods in general with the validation methods being most. Okay, next.
Yeah, I would say the same with the, I understand with the attributes in different classes.
Mm-hmm.
Probably for confusing though, is how we're using it with the
I absolutely can see that one. I will probably spend a good amount of time Monday talking about that, possibly today.
and probably checking out.
Okay, checking out. Well, those two sort of go together, right? Because the validation is sort of part of the checking out. All right? Next. Okay. 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 Go ahead. Okay. Okay, dates? Okay. Is there a patron type? There's a type of material. Okay. All right. Okay. Okay. What about the rest of it?
The rest of it is like,
Okay, and that's a fair answer. Last. Okay. Okay. All right. Let's, it seems like there are 4 main themes that come out on the fuzzy part. The design and what the appearance should look like in the format. Super and sub methods. Checking out and checking in. And then finally dates. So I'll cover some of this today, and some of it we'll leave until Monday. All right, let's focus on 1 and 2 first. We'll see how far we get with that, and then maybe we'll go on to number 3. All right. Okay. First of all, the format of the design. All right. The design should be accomplished using a class diagram. All right. Really, for the design, you have 2 pieces. You have a class diagram and a test plan. Let's talk about each of those. Class diagram look like this. This is a pretty good summary of a class diagram. All right? Where each box represents a class. Each rectangle represents a class. And I'll draw some of what we had done on the board before, because we went over parts of this class diagram before. So let's say this is my patron class. This is my library material class. And this is my book class. So to start out, you're going to have a rectangle for each class. You're then going to show how the classes are connected. And we talked about a couple different kinds of connections. Probably most relevant is, first of all, things that inherit from other things. Now, we talked about this. A patron doesn't really inherit from library materials, nor does library materials inherit from patrons. And books don't inherit from patrons, or books don't inherit from, and library material, and patrons don't inherit from books. But there is an inheritance here. And what is the inheritance between book and library materials? Which one is the superclass and which one is the subclass? Library materials is a superclass. In other words, a book is an example of a library material. Inheritance is shown with an arrow like this. Whereas the superclass is shown up here, and the subclass is shown here. You then define the attributes and the methods. So, a patron might have an attribute of a name, an attribute of email address, let's say, and an attribute of a list of checked out materials. It probably would be beneficial to put the type of these things too. Like a name is a string, an email is a string. A list of library materials is an array list of library material objects. Library materials, I think we said, had some sort of ID number, has some sort of title, and maybe some other attributes as well. You only need to put in the subclass the stuff that's not in the superclass. So I don't need to really repeat ID and title in the book class, because the ID and title is already in the library material class. But something like author, that a book has that an ID does, or that a DVD doesn't have, I would want to put there. Or number of pages, if that was an attribute in book. I would define that as being an attribute there. Finally, you can indicate a list of methods. And more than likely, it would be best to put their signature too. So for example, we have a method that returns a Boolean called checkout on the patron, and it accepts as an argument a library material. And so on. On library material, we might have a function that says get due date, is overdue, and so on. You would then only put the functions in the book that were overridden in the book class. So maybe get due date would be overridden in the book class. For clarity, I will allow you to just put a note that says that get and set methods for attributes are omitted. Because otherwise we would have to have get and set name, get and set email, get and set for every attribute. So for every attribute, the assumption is that there's going to be a get and set method for it. Yes?
What about the constructors?
Constructors, same thing. You can define them or you can leave them be for now. If you want to define them, if you want to think about what you're going to define and include those, that's fine. But I would say that's not an absolute requirement. A key thing in a project like this is how the things talk to each other. So a patron checks in a book, or a patron checks out a book, let's say. All right? That checkout method is going to ask the book, are you already checked out by someone else? And the book will answer yes or no. All right? The patron's going to ask itself, do you have more than 10 books already checked out? And the patron's going to answer yes or no. Finally, the patron's going to ask itself, do you have more than 3 things overdue? Well, you're going to look at each thing that you have checked out, and you are going to ask each book, are you overdue? And the book is going to respond, yes, I'm overdue. No, I'm not overdue. You actually can role play these objects. I've seen in object-oriented design, and I've done it in classes where people represent objects. So one person might be the library patron that's checking out a book. Other people might play the role of books. All right? And one person tries to check out, the patron tries to check out a book, the book has information about whether it's checked out or not and when it was checked out. And when you check it out, you tell the book, okay, I'm checking you out, and the date the date that you're being checked out is October 19th, 2016. And then the book's going to remember that. So when you check it back in, and you ask the book, well, when were you checked out? The book will remember. It was October 19th, 2016. So it can determine whether it's overdue or not and determine the amount of the fine. So you can actually do that. And a key thing, I think, in designing, we talked about these functions, and this even relates to a little bit to the question of how to do the validation and how to do the check-in and check-out method, is to know who is going to be responsible for what piece of information. All right? Following the good rules of object-oriented design. A book, for example, should know if it's overdue or not. That's information about a book, or a DVD, or a new book, or a new DVD. It should have that information, and the book object should be able to answer the question, if I'm returning you if today is October 19th, are you overdue as of now? Well, in order for the book to do that, it needs to know that the data was checked out, and it needs to do some calculations, and then it needs to look at how many days you're allowed to have that particular type of library material, and then it needs to say, yes, I'm overdue, no, I'm not overdue. So think in terms of entities or people asking each other questions, and if you're checking it out, how you're going to do that process. Some questions you're going to ask of the patron, because they're the patron's business, right? For example, do you have more than 10 books checked out? Well, that's a question the patron is going to ask itself. Yes, I have more than 10 books checked out. Well, then you can't check out this book. Or, no, I don't have more than 10 books checked out, in which case, no. It's okay, I can check out this book. Some things you're going to ask of the book, like, are you already checked out? And the book is going to say, yeah, I'm already checked out. You can't check me out. Or the book's going to say, no, I'm not checked out. You can check me out. Lastly, some things are going to be a collaboration between those two. The patron knows what books they have checked out. Each book knows whether it's overdue or not. So you can loop through the books that a patron has, and each time through the loop ask the book, are you overdue or not? And then it will return that. So, bottom line is, and the last thing, by the way, these don't inherit each other, but there is a connection because a patron does have a list of library materials. So if we're going to sketch out part of the object-oriented class diagram, that's sort of what it would look like. Shows the classes, shows the relationship between classes, it shows a list of attributes, and it shows a list of methods. It shows a list of the most important methods. The gets and sets, we cannot worry about those. The constructors, we cannot worry about those. Not because they're not important, but they're sort of assumed. The other methods are really the methods that you're creating to actually do the operation that you want to perform. All right, questions about that? I would say, and again, it looks like this example does a little bit different. This example repeats on the subclass. I don't think that's necessary. Only put the stuff in the subclass that isn't in the main class, or that's overridden from the main class. All right, so that is design, the appearance and the format of it. Let's talk about super and sub. All right, where is that most relevant here? Let's look at the instructions. It's most relevant here in two regards. I'll change that and I will say three regards. First of all, you're going to have a structure that looks sort of like this. Library material, book, DVD, new book, new DVD. Now, if we look at this chart, we see that there's two things that are different depending on the kind of library material. Every library material has this, all right, but every library material, every kind of library material has its own way of calculating it. So, in other words, we are going to define every library material needs to be able to tell me the daily fine. Or rather, it needs to tell me what the fine is. Calc fine. Everyone also needs to tell me, every library material also needs to tell me to calculate the due date. These are two things that every piece of library material needs to be able to do. To calculate the fine and calculate the due date. Now, in this case, it's different for each kind of library material, both the due date and the fine. So every one of these is going to have its own calc fine and calc due date. So, we have in our patron a list of the checked out library materials. That's going to be an array of library materials. But those library materials might be books, DVDs, new DVDs, or new books. So as we loop through, or if we go and return a library material, a piece of library material, we're able to ask it what your fine is. All right? Because all library materials have a routine to calculate fine. That's defined in the superclass. Now, we will get, however, the correct calculation because of the way the object is created. So our code is going to look something like this. Our test code would look something like this. P patron, P equals new patron. Then let's say we set the values in the patron object. Book B equals new book. And we set the values in the book class. I then will be able to say P checkout B. All right? Why will I be able to do that? I will be able to do that because our method to check out a book or to check out any library materials, it accepts an argument of library material. And because a book is a library material, I can give that function a book. That's what's known as polymorphism. I can give it a book. All right? Now, when I do the calculation of calculate fine and calculate due dates, which of these method gets called? Well, since it was a book, it will get the proper method for calculating the fine as defined on the book and the proper method of calculating the due date. Just like in our pizza example, the price for a stuffed crust pizza got calculated. Even though our order only accepted pizzas, our order didn't care about stuffed crust pizzas. It simply had a list of pizzas. But because stuffed crust pizzas are pizzas, we're able to add stuffed crust pizza to the pizza order. And when it comes time to calculate the price of that pizza, it uses the function in the stuffed crust pizza class and not in the pizza class. So if we do this then, when we get around time to asking what the fine is for that book that's overdue, it's going to use the proper function defined for the book. All right? We're able to call it calc fine because all library materials have a calc fine method, because that is encoded in the ancestor, probably as an abstract method. But we're going to get the right version of it because that's defined on each subclass. So that's two of the ways that it's important, for the fine and for the due date. The other way that's important, and maybe this is what you meant, is as far as like chaining constructors together. So for example, let's say we had a constructor on library material that accepted the ID number and the title. And then we had a constructor on the book, let's say, that accepted the ID, the title, and the author. All right? We can do what's called constructor chaining. Essentially what I want to do is, the library material class has the code to handle these two fields. The book is going to have the code to handle the author, because only books have authors. All right? So what I could do is I could say super and pass the ID for the argument and the ID for the title, and then set the author to the argument that's passed in. So you use super when you want to call a method on the superclass. Generally speaking, the superclass is never going to call a method on a subclass because the superclass doesn't know what subclass it has. But the subclass can call a method up on the superclass. Likewise, if I had a constructor on the new book class that accepted the same three arguments, I could simply say super and pass those arguments up to the book class's constructor and let the book class's constructor handle it. Because we're not going to set the title or ID or the author any differently if it's a new book or if it's an existing book, a current book. All the super does is allows us to call methods on the parent class. All right? And it's especially useful if it's especially useful for two things. One is if there are constructors and you want to chain them. and you want to take a constructor from one class and call the superclass and let it do the handling. The other thing is if the calculation of one class is based on the calculation of the superclass. For example, if I were to change this to say the fine of a new book is twice the amount of a regular book, then I could simply call the regular book's calculate fine and divide it by 2 or multiply it by 1/2. All right? And that way I wouldn't have to duplicate code. But in this case, notice there's no correlation really between the two. Actually, there sort of is a correlation between the two. Really, the fine for a regular book, or fine for a new book, is simply whatever the fine for a regular book is plus $1. So I could use the super function to get the fine for a regular book and simply add $1 to it. I could do the same thing with DVDs. So I guess I could use the super in that case too. In other words, if I have a new DVD, I could ask the superclass, well, what's the fine for a DVD? And then taking in and adding $5 to it. And that's the fine for a new DVD. Questions? Monday we will talk about those methods and we will talk about dates. All right? Again, I'm going to go upstairs and start grading the designs that have been turned in so far. If you have not turned it in, turn it in as soon as you can. If you come up to lab, I'll talk with you then. If you don't come to lab, then just be sure to read my notes. All right, any questions? All right, we'll see you later.